Okay, I'm going to assume that's a good. Here, I'm going to turn off the sun. Oh, got it. Oh, yes. Vertical. So it's this one here, right? So I had a full worked out problem about how to find the standard deviation. Blah, blah, blah. I had some more problems. There's the Z-score that we talked a little bit about. And again, I really want to hammer this home. When we calculate the standard deviation, that naturally makes sense as a unit of measurement. Standard deviation is how far away, on average, the data points get. So I can use that as a step size, right? So data that is 2 standard deviations away from the mean, that gives me an idea that's pretty far away, because that's twice as far away as average. Does that sort of make sense with you guys? Mm-hmm. So to me, standard deviation is like, when I calculate, it's sort of like picking inches or feet or miles. I calculate it, it's what I'm going to use. And the Z-score is what I get when I put the ruler down that I make. So every step is this big, and then I put the ruler down and I measure. In this case, it wasn't even a full 1 on my ruler. It's not even a full step down. I like it, right? Because how far down is 2 from 5? It's 3 down, right? Mm-hmm. And every step is 3.5. So of course it's not even a full step down. Kick ass. I like it. So I would say that's relatively close. You still don't want that as your grade, because you made below average then, but you're not like really far below average. Okay. So let's look at this side. And let me show you how to do this in the calculator, because it will drive you crazy trying to do each step one at a time. Does anyone need to borrow a calculator? Let's do that exciting transaction. Bring up ID. Which kind do you want? Okay. Which kind is okay. All right. Okay. So let's all do this together. Let's see if I can create this thing. Turn this light on. Where are you at, light? There. Oh, yeah. Jeff Coleman. Okay. All right, that's not too bad. This looks like a calculator. I am your world. Okay, so let's put this data into list 1. Let's clear out all these lists, right? Clear, get the hell out of here, get it out of here. Clear you out, yeah, that's all nice. So now you can't see it at the moment, but I'm gonna put in there the data, right? The 6 and 7, are you guys with me? Go ahead and put the data in there. The scores on this quiz.
Excuse me?
Yes?
Are you clear again?
Oh, so this is fine. So if you go up to the list and then hit the clear button, which is, I guess I can't have everything.
Put it into?
Oh, there's the clear button. Yeah.
Thank you.
And then enter again. Oh shit, I should have done it. All right. So now I want you to put these grades in. That's good. You can still see it, Jeff. It's all right. 6, 7, blah blah blah. This. Now, I mean, to find the mean, you can still add them all up and divide by 12, because there are 12 of these grades. Right? Or I could do, let me remind you, if I go to second, stat, to get the list, I can then do math on my lists. I could actually do the mean. Just list. But let me do list the sum of list 1, just like that. Is that cool? List 1 is right above the number 1. So let me know if I leave you behind. Enter. So I get 78 divided by 12 people, I get an average of 6.5 on this quiz. How you guys doing out there? Yes.
How did you do that with?
Did you get the sum? All right, let me do this. So hit second stack to get to list. So you see that names, ops, math. I want to do math on a list, right? I want to sum a list. You with me? And then I want to sum up list one, and that's right above the one button. So I hit second one to get list one. And then I can divide by 12, and I get an average of 6.5. So let me put that down. You basically don't want to round your mean. And I'll tell you if I'm going to let you round on the test or something. All right, so now I could do each one of these rows by hand, one at a time. That would suck. This thing costs $100. Calculator, do this for me. So let's go back into our list, and look, I've told you what you need here, right? I want list 2. The whole idea of this is to see how far away each data point is, and then try to find an average. Of course, we've got to square it to kill the negatives. We kind of talked about all that. So the very first thing I want to do is take every x and subtract the mean. Well, where are all the x's? They're in freaking list 1, right? So if I go to list 2, so now I got to highlight list 2, go up there, bam. Now see at the bottom, it's telling me, okay, what's L2? What do you want it to be? I want it to be every damn thing in L1 minus 6.5. I want to see how far away they all are, right? So I'm going to put in there second one for list 1. I want everything in list 1 subtracted by 6.5. Kabam! All right, Jeff, go on. Make this better? Yeah, it's better. Okay. Right, and then on a test or quiz, you can just copy that down into your table. Okay, and then, yes?
I'm having a problem, I don't know how to do it. It's like you care.
What's the error? Yep. Notice nothing. You want to go to list 2. You don't want to overwrite list 1. So tell it you want it to be list 1 minus 6.5. So that's the problem. You're trying to tell it to subtract itself. You know? So it's like, what? What are you doing? Okay.
Does the data points have to be in order?
No.
Okay.
Mine aren't, right?
No.
Some people like it. I kind of like it because then there's some repeats, but it doesn't matter, right? Okay. I'm not asking you to calculate a median or a percentile, so it doesn't really need to be in order. Okay, so you can copy all that down. I'm not going to. Do you have to on your test? Of course you do. And then what do I want L3 to be? Of course, that's where we all talked a little bit about what plane you want to be on and all that kind of weird shit. We got to kill the negatives, but we have to do it in a way that's mathematically nice. And squaring is much nicer than absolute valuing something. So I want to go to L3. So go up to L3, and I want to square everything in L2. L2 squared. Bam. And you would copy all that next time.
I'm sorry, can you show that again?
Sure. Delete this clear. So go to L3. Let me try to spread this up just a little bit. Go to L3. Tell it you want it to be L2, second 2 for L2, squared. Bam. Oh, scheisse. That's better, Jeff. All right, and of course, all right, let's take a look back at our sheet here. So I need to put something up here, right? So this last list, isn't it the x minus x bar squared? Isn't that what that is? So the formula wants the sum of those. So what do I need to do in my calculator?
Sum L3.
Yeah, so if I get second mode to get out of my list, then I can go back to second stat to go to list. I want to do something to a list. I want to do math to a list. I want to sum up a list, number 5. I want to sum up second 3. I want to sum up L3. Let me do that again. So I want to add a list up. So I want to go to the thing that says list. I want to add it up, that's math. I want to add it up, that's sum. And which one do I want to add up? Jeff, what have you done? You crazy fool. Go to your list, you want to add it up. Number 5 is the sum, and I got to tell it which list. I want to do list 3, second 3. There it is. So that is the sum of these. So the biggest mistake people make is, and this is not entirely your fault, but I see people putting stuff in for x and stuff. I mean, that's, you're used to that from algebra, right? You find x and you put a number to the damn thing. Well, here, what is our variable? Sum of x minus x bar squared. That's the whole damn thing is 69. That's where I put that. You guys see that? You can't plug stuff in. The sum of those is 69. And what's n?
12.
12, so I divide by 12 minus 1. Of course, I'm doing the n minus 1 thing because this is a sample of grades. It's completely fine to round on your paper, but you do not want to round in the calculators. Let me show you what I mean. So down for your paper, what's the variance? You can write 6.273 roughly, right? But in the calculator, I want to take a square root of that whole damn number. So the quick way to do that, one of the coolest, really, Jeff? One of the most useful buttons. Let me hit square root. And which button has this in memory right now? You guys remember?
The negative.
Yeah, above the negative, the ANS button, right? So if I hit second negative, it's the square root of the last answer. So now I'm not rounding. I'm not going to get some number that's too far off. All right, let me stop for a minute. You guys doing okay? You can back me up to any step you want to. What step did I lose you? I lost a few of you guys. Look, I can see some of you guys, your eyes are saying, you lost me at hello? But, I mean, which part do you need help with? Just tell me.
Yeah,
Okay. All right. Let's just do all that again. Let's pretend like I didn't do anything yet. I've got the data in my calculator, right? And again, I just want to remind you guys that you don't have to use the list. If you want to do each, so this would be like 6. This would be 6 minus 6.5 is 0.5, and then you can square that. Yes, negative 0.5. You guys, I mean, you can do each row if you want to. Nothing wrong with that. That's fine. I'm just trying to show you a bit of a shortcut. If I go to L2, see how I'm on L2? I can then control what list 2 is. And what do I want list 2 to be? I want it to be everything in list 1. So I'm going to do second 1, everything in list 1, minus 6.5. I want all the x's. Where are those? In list 1. Okay, so I want everything in list 1 minus the mean, which is 6.5. So I'm telling the calculator to build that list for me. You guys okay out there?
And you got 6.5 by,
Remember that's what we did here?
yeah.
Yeah. So that's not always 6.5. It's 6.5 because the average was 6.5. Is that cool? just like on the front it was 5, because the average was 5 for this data, that's all. So it's always the average of the data. All right, so if I do that, I get those. If I added those up, does somebody remember what they have to add up to be?
0.
Yes. And that's why we had to do another step, because we always got 0. That doesn't tell me anything. So that's why we have to go to L3, and we want to square all of these. So we kill the negatives. So now if we go to L3, what exactly do I want to square? I want to square everything that is in L2. So I'll go to L3, and I tell it, see how at the bottom it's like waiting? L3 is what, dude? L3 is second to list 2, square. Bang. Bang. And then just copy all that stuff down. Okay.
How did you get the 69?
So again?
I did 69.
Oh, okay, now. Coming back to the idea. This is the formula here, right? Okay. I know I need to add up all of these. Which list has these in it? List 3 does, right? Doesn't list 3 have the x minus x bar squares? So I want to add them all up. So if I add up, what's wrong with my, if I add up list 3, that's going to be exactly what I want. That's going to be the sum of those. So that's where we did this. First, get the hell out of your list. Second mode, to quit. Right? Then you want to do something to your list, so you go to the button that says list. You want to do math to a list. In this case, you want to sum up a list. And I want to sum up second 3. I want to sum up L3. What's really kind of nice is if I hit second enter, I just get the sum back. I could go back and sum up L2 and make sure it's 0. You see that? So if I already have the sum up there, I don't have to go through all that list shit. I just hit second enter and I've got the sum again. Yay! Okay. So the table, we went through why it makes sense. We wanted to find the average distance from the mean. So we figured out how far everything was from the mean. We squared it to kill the negatives. We're going to add those up and divide by about how many there are. Why is it divided by n minus 1, not n? It's a sample. We're going to adjust for that. Poor little sample. All right, so now we're caught up. So now we got 69 for these, divided by n minus 1, 11. We got this bad boy roughly. Divided by 11, shebang. And then if I do square root of answer, I get my 2.505. All right, let me stop for a minute.
Okay, can you show me you did the square root again?
Yeah. So start fresh. Get out of there. So 69 divided by 11. Bop. Square root of second negative to get answer. ANS. That has the last thing that was on the screen. Okay. That ANS button is stupid useful. It's going to be really useful later this semester. It's useful right now. So it's temporary memory. Okay. And let me show you. Let me show you something. And this is where students kind of go, why did I do all the work? You did all the work to learn. Let me show you how to make the calculator calculate S for us. Right, it costs a lot of money. You should be able to do that. That doesn't mean that when I say show work, you write what buttons you pushed, right? Because then let me make my whole joke. Because then the calculator passes the class, it has a nice life, and you can take the class over again and all shit. So, what? But to check your work, if I hit stat, calc, that's where we go to calculate something based on what we put in the list. Remember we did one var stats to find the 5-number summary? Do you guys remember that? One var stats, I scroll all the way down. There was something up there before that. If I do one var stats on list 1, what do you see?
S of X.
Yes, I like it. Later this semester we'll figure out why it's got a little X there. One reason is if I had multiple lists, did you see how the second option was 2 var stats? So if I had 2 lists, it would call this one X's and it would call this one Y's. So there would be an SX and then further down there would be an SY. Okay, but there's another thing about this that we'll learn later. Why can't I just use this one? What's this one? What's the difference?
Population.
That's the population density, so why can't I use that one? Isn't that better?
No, because that one you divide by the whole number instead of n minus 1.
True. But isn't sigma better? Isn't it better to know the population one?
Not if you're looking at a sample.
Yeah, that's the problem, exactly. We can't choose because it is a sample. Why does the calculator give us both? Because the calculator's dumb. Stupid thing. We made it. It's dumb. So it's like, I don't know, human. If it's a sample or population, there you go. I don't know. You guys kind of understand what I'm saying?
Yeah.
Later in the class, that gets confusing for people. They're like, but I know sigma. Look, it told me. I'm like, you're smarter than the damn calculator. It's going to give you both because it has no idea. But we're the humans. We go, it's a sample. I better use S. You guys understand?
Mm-hmm.
Okay. All right, I like it. Now, here is that idea of the Z-score. Remember that? And let me say this. This is huge. This is big. Get ready to take a note somewhere important. What does a Z-score tell you? Always. I don't know if anybody remembers. It tells me how many of these fit into this, right? So let me say that more technically. It tells me how many standard deviations there are from the mean to the data point. That's what it tells me. So if I did a Z-score and I got 2, that means that data point is 2 steps above the mean. What do I mean by steps? Standard deviations. Let me be more technical, right? Let me say this again. Because this question that I'm just now giving you the answer to is going to be on every test. And someday I'll get more than half the class get it right. All right, here it is. What do you always want about the test? Don't you always want to know what the questions are? All right, here's the question and here's the answer. What does the Z-score tell you? The number of standard deviations from the mean to the data point. That's all it does. Yes. The standard deviation, I'm sorry. The Z-score tells you the number of standard deviations from the mean to the data point. Now, so that her question was, are there more questions from the test I want to tell you? And no. Or actually, yes, I've told you the answers to everything, but just have to pay attention. But that one I'm telling you very specifically. But I wish you wouldn't just memorize it. I understand you're going to memorize it because you know I'm going to ask you, but let it make sense. That's what it does. It's, you know, again, my point was, if I'm standing at 9 and I want to get to 13, let's say I'm at 9, you with me? And I want to get to 13. And every step I take is too big. Not too big, but 2, right? How many steps will it take to get me there? 2. 4, the distance divided by 2, each step size, right? I'm there, hey. So that's why, if I take the distance I gotta go divided by how big each step is, it tells me the number of these between this and this. Okay. All right, so what about this? The data point of 8. I want to know what it's, how many standard deviations from the mean to that data point. So a quicker way to say that is, I want to know the Z-score, because that's what the Z-score tells you. So what do you put in place of X?
8.
8, beautiful, that's the data point I want. Of course, what's X bar? Still 6.5. And what's S?
2.505.
Good, that's how big each step is. And then whatever the hell you get. 15 over 25, 3/5, 0.6. 0.592. I don't know. What is it? What is it? How far off was I? Am I really far off? I'm trying to do it in my head, so I'm gonna give myself
I
a
got
little.
5.9880.
0.59 something, right?
Yeah, is that what I said?
Is that close to what I said?
I don't remember.
I did
don't
it in
even
my head,
remember what I
man. It's
said.
pretty good. Yeah, okay, sorry. So 0.598, whatever the hell, blah, blah, blah. Okay. So I'll tell you this, we normally round Z-scores to 2 places. You'll see why later this semester, but I'm not gonna make that a hard, fast rule yet. Later this semester, we're gonna have a chart that only goes out to 2 decimal places, so. Okay, yes?
Will you round it up on the test?
Yeah, if you round it to 2 places, kick ass. I love it. Okay, now. There is a, let me do this. I'm gonna transition a little bit. And then we'll do this next question up there. Come on. Come on, little dude, there you go. You turn the sun back on. It's kind of neat. That's kind of nice. All right, so there is a theorem. Well, actually, there's a rule about normal curves, normal distributions. Here's the idea. This is a very kind of prescribed shape. Would you agree? Right? You can tell very quickly if it's not quite normal. Yes?
Mhm.
Isn't most of the data in here?
Yeah.
Where would the average be? It's got to be in the middle, correct? Okay, so this is the average. So here's something kind of cool. If I go up and down 1 standard deviation, so let me do this. Can you guys see that? Right, kind of small. Mu plus sigma, mu minus sigma. Let me do that better. Let me write some numbers and let's see if you guys see what I'm writing. I'm going to put 0 under there, 1 under there, 2, Jeff, -1 under there. What are those? What?
Those are your answers. Those are standard deviations. So your standard deviation is 1.
That's the number of standard deviations. Isn't this 1 step up from the mean? Right? Isn't that isn't that Z-scores then?
Yeah.
Aren't these Z-scores? Okay. So if my test was here, above the mean, I would have a Z-score of 1. I'm 1 standard deviation up above the mean. So then if I go 1 more step up and down, it'll of course be 2 and -2, yes?
Yeah.
And then 1 more step would be 3 and -3. It's just a nice quick way to talk about where I am on the picture. So here's the thing. No matter what your mean is, no matter what your standard deviation is, if it is normal, there will be about 68% of the data in here. That's kind of neat. So, for example, heights of men, which is a really boring sequel to City of Men, or heights of men are normally distributed with an average of 5'9". So Jeff is exactly average. So I'm right in the middle. Right? You guys with me? It's normally distributed. So 68% of all men are 1 standard deviation away from 5'9". Standard deviation, let me see if I remember. The mean height for American men, you're dying, aren't you? Oh, the mean height for American men is 69 inches. And I believe the standard deviation is 2.8. I can't remember. I think it's 2.8. I really want this to make sense. I know they're normally distributed. In fact, that's part of the reason we call it normal. Most men should be in here, correct? Over half of men are in there. Very few men would normally be found down here. Right? This is your Warwick Davises and your, right? The guy that played Return of the Jedi. Yes, okay. I don't know. And then, of course, you got your Yao Ming and your why did I forget his name now? Manute Bol. Very tall people. Yes, maybe? No? You guys with me? So normal. This is normally how things flesh out. Most people are here. Very few people out there. Okay. So, for example, if this is the mean, and that's the standard deviation, one step up would be 71.8. Is that cool?
Yeah.
And one step down would be, I don't know, I'm tired, 66.2?
Yep.
So here's the neat thing. 68% of all American men are between 66.2 inches and 71.8 inches tall. Because we know the mean, we know the standard deviation, and we know it's normal enough. It's close to normal. I like it. So this is kind of related to why they make the door as tall as they do. Kind of with me? You want to make the door tall enough so that most people don't have to duck to go through it, because you want to decrease the number of complaints or the number of people that are passed out from hitting there. I'll see you, man. Right? That's not good. Yeah. If we were all hobbits, we would have much shorter doors, just like in the movies. Gandalf would come in. Right. No? Okay, it's just for me. All right. Is that? So here's the next step. If I go one more step out, I get 95% of my data. That's interesting. What would you think then? If 95% of everybody is between here, what height would that be for dudes? And my apologies, I don't mean to focus on biological men, but that's just what I'm doing right now. So if I add another 2.8, I get 74.6, is that cool? And if I subtract another 2.8, oh, Jeff, you could do it, buddy. 63.4, is that right?
Sounds good.
Sure. So 95% of all men are between 63.4 and 74.6 inches tall. That is 5'3.5", up to whenever that happens. What is that? Is that 6'3" almost? I think. I'm tired. All right. Doesn't that jive with what you like? How common would it be to see a dude shorter than 5'3"? Would that be very common?
No.
In America? No. How common is it to see a dude above 6'3"? Is that? Yeah, I know. So I appreciate you doing that, because sometimes people will take what I'm saying and it sounds like I have an example later this semester about a Harley Davidson, and I say the probability it's a dude goes up if I know it's a Harley Davidson. Someone's like, there are women that ride. I'm like, it's probabilities. I'm not saying nobody. I'm not saying no women ride Harley Davidson. I'm not saying that there's nobody that's 6'3", but are there a lot of people that are out here? No.
I mean, less in comparison to everybody else.
Yes, exactly. Less in comparison to everybody else. You could find somebody, but there's not that many. I forgot my point. All right. So that's why I like to do a problem like this to relate to this. So theoretically, if it was normally distributed, I should see 68% of the data within one step. You guys with me? So then I like to do a concrete example of that freaking theory shit. I want to do a concrete example. I'm like, I have a freaking distribution. Let me just go see how much data there is within one step. Turn the sun off again.
It's over here.
Pen black hole. There it is. Thank you. Oh, check. So if I put the mean in the middle, just like it did up on the board, 6.5. Somebody help me out. If I go up one step,
9.005.
9.005, and if we go down one step,
3.995.
now, how much of the data did I just catch? Did I catch the people that made a 2? No, I didn't. And this is where if it was in order, it would be nice, but oh well. I didn't catch the 2s. Did I catch the 4? Shit, sorry, you can see. I didn't catch the 2, right? The 2 is not in there, I didn't catch it. Did I catch 4?
Yeah?
Hell yeah, it's in there, isn't it?
Yes.
All the way up to 9. So I caught the 4, I caught the 9, I caught the 6, I caught the 4, I caught the 7, I caught the 6, I caught the 5, I caught the 7, I caught the 8. So I didn't catch the 10, the 10, or the 2. So, oh shit, you didn't see any of that. Oh. So I caught 9 out of 12 of the data points, yes?
Yeah.
And what percentage is that?
Around 68.
No.
Um,
There's nothing here that says this is normal, right? I have no idea if this is normally distributed.
oh.
9 divided by 12 is 75%, right? This is 3/4 if we reduce it. So that kind of speaks against this possibly being normal. Of course, it's just a little sample. You never know. All right. Woo! That's why I ask this question, because we have this theory, and that's just a concrete example of what that theory is saying. If it was normal, I would have caught closer to 68%. Okay, so let's transition to, let's create our formula sheet. Then I'm going to open it up wide to whatever questions you got, homework or practice test questions, right? All right, so go back. There we go. Yay. Kinda wish somebody was walking on the roof and they're like, what? All right, so this is what your formula sheet can look like. I'm gonna put it up here. What is blocking you? You
Are we using our own paper?
To make the formula sheet?
Yeah,
Yes.
just curious. Okay, just curious.
Okay, so obviously, you're gonna turn the formula sheet in with your test, so. I really love it, somebody made their own language and was doing stuff, or, no. I don't wanna see any marks, anything. You with me? No notes can be on your formula sheet, no words can be on your formula sheet. Okay. Just formulas, and there's not that many. We have very few formulas so far, right? No formulas in chapter 1, really. You have to remember class width formula. I'm not going to let you write it down. You have to memorize it. How do you figure out the class width? Yeah, high minus low divided by the number of classes. You guys hear that? So don't write that down on your formula sheet because you're not allowed. So we only had a couple things. We had the mean formula, yes? Some of you guys might not even want to write that down because you already know how to find the average, but at least this will kind of remind you of symbols. What does that mean?
Mu.
Okay, the
Population.
letter's mu, what does it represent? The mean of a population, good. So the sample mean is the same damn formula. All right, so again, if you don't want to, you don't have to write this down. You know how to figure out averages. But then we've got these bad boys here, right? So I kind of like to do it like this. Just to remind myself, this is the variance, this is the standard deviation, right? You guys with me?
Another day. Another day.
Well, it's that
Oh, this year?
simple thingy.
Oh, my J's. That would be funny if my J would have come all the way around. It does look like Simba. Simba? Simba, Jeff. circle of freaking life. All right, yes?
Can we write numbers in them, kind of like showing you as an example of
Nope,
the formula?
no examples. So evil.
Yeah.
I could have made you memorize all the formulas. You want me to do that? Really unleash my evil? No? Good. I'll try to keep it in check. And next to this, I would write, is that all you need?
What do you mean?
One more thing you want, right? What do you want? What do you want? This is the one for the population. You want the one for the sample, right? And the only two differences here, what are the differences between the S and the sigma?
N minus 1.
There's an N minus 1, and this will be
I don't know. X bar.
X bar. Oh, Jeff, really? Just had a stupid joke in my head about Admiral X bar.
So
It's a truck.
the test is on Tuesday or Thursday?
What do you guys think?
Well, I thought you said Thursday, but now we're doing test prep today. So now I'm confused.
Right?
Yeah, I didn't change the test date. It's Tuesday still.
Why do I feel like anyways.
It's the
Do we have
optimistic-
something on Thursday?
Optimistic part of your brain.
I don't know. Yeah, I don't know. I just got ahead of myself.
That's all right.
Double check, Muse for population, right?
That's right.
Okay.
So Muse for population, X bar for sample, sigma. So right now, the Greek letters represent population, our letters represent samples. Okay. Any other formulas you think you should have on there?
The one for X4? The Z-score. I don't know.
Oh, there you go.
My brain today.
Zscore.
I was like, what do you understand about
I'll put two versions of this. Do you understand how those are the same formula?
Yeah.
This one's if you have a population, that's a mean. I'm sorry, a sample. Today's been a long fall. All right. Yes.
Also, you said we can't label them?
No.
The words you said on the formula sheet? For example, can we say like this is for the population on there so I remember?
This is all you can have on your formula sheet.
So
This
no
is-
words or anything?
No words, no marks, no weird shit. No, don't turn it in like with part of the paper ripped off. Don't turn it in with a bunch of stuff scratched out.
Can I write formula sheet?
Yes, you can have the words formula and sheet. That's fine. Bless you. Cool. All right. Now,
I'm sorry, I just wanna make sure I get this right. So, all of these formulas, a lot of them are this, somewhat the same, each one's for population, one's for sample, right?
yeah, basically, yeah. Yeah. So, the two for the mean, same formula, because to calculate the average doesn't really change. Standard deviation has a little bit of an adjustment because of what we talked about with the sample being closer to its average, so it kind of throws it off. And the Z-score is basically the same formula. In fact, we're gonna see a bunch of different Z-score formulas, and I'm gonna argue that they're all the same formula. Some of you guys are gonna think I'm weird, as you already do. And I don't care. Any other formulas you think I forgot, or that you wish I would let you have on there?
If we do happen to find one, can we put it on there as long as there's no, words?
If you do what?
If we do happen to find any other ones, are we
No,
allowed to put it on?
not unless I put it up on the board right now.
Okay.
Otherwise, this is all you can have. All right.
And we put the formula for percentile on it?
Nope. You gotta know that process.
It was for
It wasn't,
I do know
it was
it.
definitely worth a shot. I don't blame you. Okay, so, let's transition to, everybody got an answer key, right, for the practice test? I think, Kenesha, did you need I think you need one, right? piece on that practice test answer key that I said I would do in class. Ask Jeff is such a lazy work. Right there. Right. So, keep this up here. I'm going to do the work on the board. So part G is the box plot problem. Yes. 5-number summary, and then make the box plot. That's good. You guys can see that. So how do I find the 5-number summary for a list of data? What is that?
Five
The high,
number.
the low, and the
3/4.
and the quarters. I love it. Everybody got all these?
Oh, so like this, only for chapter 2, right? And not chapter 1.
Yeah, chapter 1 didn't have any formulas, right? It was all definitions. It had the frequency distributions, but there's no real formulas for those.
So it's only on the test on
Oh, this will totally be on the test. So this test is chapter 1 and 2.
Oh, it's both.
Oh, yeah. Okay. But does everybody have these written down? Okay. All right, so we've done quite a few of these, so this shouldn't be too taxing. The low is 29. The high,
63.
63. How many data points were there? You got a copy of this. The city of Townsville. I didn't tell you, so you gotta count, damn it. How many were there?
Over the
15?
past 15 days.
Oh, there it is. Look at me being nice. So how do I figure out Q1? What are the steps I take? So there's 15 data points. What does
So you do
Q1 mean?
0.25.
25th percentile, right? So I want to go 25% of the way into the list. I want this just to make sense. It's nothing to memorize, it just makes sense. I want to go 25% of the way into the list, and it's 15 long. So I want to go 25% of 15. 3.75. What does that mean? If I get 3.75, what do I do?
Round up to 4.
Good. If I get a decimal, I round it up no matter what, and that is the answer that I go find, right? 4 is not the answer, the fourth number. So the fourth number, looks to be 40. Yes? Okay, I like it. So then Q2, of course, is the 50th halfway. So I want half of the list. I want to go halfway to find it. Half of 15 is 7.5, rounded up to
8.
8. The eighth number of the list. 1, 2, 3, 4, 5, 6, 7, 8. Somebody already said 45, right? Sorry. And then Q3 is 75%. Whatever the hell that is.
11.25.
Sounds good. Go up to 12. So the 12th number is the answer. Yeah, the 12th number, 52. I like it.
Quick question, so if it is let's say you didn't have to round to get to that number, aren't you going in, let's say it totals out to 4, you have to go between the 4th and 5th
Yeah,
number and.
so if this would have been a whole number,
Yeah,
I would have to average that with the next.
okay, so would it be the 4th and 5th number you find, add them and then.
Yeah, if I would have gotten 4 from this work,
Uh-huh.
then it would have been the 4th and the next one, 5th.
Okay, and then divide by 2.
Yep.
Okay.
Cool. And again, the easiest example is if I had 4 data points, P50 should be right there, but half of 4 is 2. Oh, second and third averaged. Okay, that makes sense. And then to make the box plot, what is one of the most important things about making the box plot? What do you have to put down first?
Even scale.
Yes, your scale has to be consistent, right? So I want to go from 29 to 63. So let's start at 25. I want to make it up to 65. So maybe I can go by
Fives.
fives. Sure. 25, 30, 35, 40, 45, 50, 55, 60, 65. All right. Oh God, Jeff, your scale sucks, but oh. You can count. Okay.
Okay.
And then, of course, by this time, we've done enough of these, but I guess I just ran out of room on there. 29, put a line. 40, put a line. 45, put a line. These are the only lines you should do, kids. 52, 63, that joke never gets old. Yeah, thank you so much. The box of the middle three, whiskers out to the low and the high. Look how nice and balanced that is. Does that make sense for me to say?
Yeah.
Isn't it kind of balanced?
Really great.
Put your thumb in your fingers in the middle, and it would go. That's much better than, something like this would be crazy. It's really not balanced. Get out of here, you weird thing. Yes.
And if you have the same value for one of the percentiles,
Yes.
then you just do the dotted line?
Yes. If you ever have to overlap two lines, you put a dotted line there just to show that you overlapped. Couldn't like many overlap?
Yeah.
What kind of data would have a box plot that looks like this?
All the data is the same.
All the data is the same number, right? Because then every quartile would be the same number, the highest one. So it was 3, 3, 3, 3, 3, 3. Low is 3. Q1 is 3. And that's the only
So-
freaking thing anything could be. So that would be dumb to make that box plot. I wouldn't make
It would be dashed or it wouldn't be dashed?
Yeah, it would be dashed. That's the one.
Okay.
But it's kind of, I wouldn't even do it anyway, so I wasn't really.
Oh, so we just ignore it.
Yeah.
Okay.
And that I would just put a sentence. All the data was the same. I wouldn't actually analyze it because.
Yeah.
Yeah. What would the standard deviation be for that?
0.
0. None of them get away. They're all of them there. So the standard deviation is 0. Yeah. Okay, I like it. Yes.
When you're finding the range, so on the paper E, do you always want to do those columns where it's X, X minus, X bar?
Wait. The range is just that 34. That's it.
Wait.
All of this work is to find what?
The.
Standard deviation.
Okay.
So the range, that's it. That's what the range is. The
Okay,
range is
it looked
34.
like it was with range.
Yeah, I'm sorry.
So whenever you do to find the standard deviation, you want to put all of, like that would be the.
Yeah, remember that's just like that thing we just did, the L1, L2,
Yeah.
L3. Yeah. That's what you gotta do, because the formula was the sum of x minus x bar squared divided by n minus 1. So that's why I sum these up. Bam! Divided by n minus 1. Yep.
And all of that is variance? Or is this-
Before I square root, that's the variance. And then after I square root, that's the standard deviation. So what is this? Can anybody tell me what this means?
That's how big your steps are.
Okay. Now a little more specific about the data. Oh shit, nobody can see it at home. Sorry, my sick little kids.
That is the average of how far apart the data is spread.
From the,
Mean.
good, so that is on average, the data points get about 8.6 almost steps away, right? Not steps away, I say steps. On average, they get about this far from the mean.
Wait, so what's the standard deviation?
That is the standard deviation.
Oh, okay.
Z-score is the number of these from the mean to some data point. So if on average the data points get this far away, a z-score of 2 means it's twice as far to get to that data point than average. That's why a z of 2 would mean really far out there. If your height was a z of 2, you'd be way the shit up here, right?
Yeah.
Of course, heard to Jeff. All right. Now it's wide open. Whatever you guys have questions about.
Why is, number 4 per C, why is it ratio?
Where are we at?
Number 4 per C, the
Oh.
number of text
Yeah, notice I didn't say to explain, so I didn't explain. But yeah, the average number of TVs. So, could there be 0 TVs? Does that mean the absence of TVs?
Yeah.
Yes, 0 would mean the absence of TVs. Ratio.
So
If some,
ratio,
yeah, go ahead.
is ratio like the most important thing for ratio is that 0 means nothing?
That's the quickest check.
Okay.
The other way to check it is, if one person had 6 TVs and another person had 2 TVs, does the division mean something? Yes. 6 divided by 2 is 3. This guy had 3 times as many TVs.
Yeah, okay.
So that's why it's called ratio, because it's division. But in order for division to make sense, 0 has to be in the right place. That's
Okay.
why Fahrenheit temperature is not ratio, because 0 is in the wrong place. 0 does not mean absence of heat for Fahrenheit, right? Thank God, some states are like, thank God, because we routinely go below 0, and what the hell would that be?
So I'm confused because on this quiz too, choose the number of classes, and then when we were talking about it, you said 5 classes.
Yes, totally, but the work, how do you find the class width? High minus low divided by number of classes. So that's what was missing for me. I didn't see how you got that width.
Yes.
Yeah.
But then you said too many classes.
You put 9 classes.
Yeah.
That's too many.
Why?
Because what did we,
Between 5 and 10.
the 5 and 10, when do you choose more classes? When your sample gets really big.
Big.
Is
but
that sample really big?
I just wanted it to be really specific.
Oh, I see. All right.
Okay, I'll take notes.
Well, that's too many. I kind of told you that the most you would use for this class is 7, I would say. I'm never going to
Okay.
give you like 800 data points. Yeah.
Okay, anyways. And then next question. On quiz 1, what would the number of words you can type per minute? What would that be?
Ah, okay. All right. So I really want you to understand. I don't think a lot of people did this, but there were the words per minute. At least a couple people said it's ratio because I divide words by minutes. No. Ratio, all of those are how do in data values compare to each other. If one person typed 80 words a minute and somebody else typed 40 words a minute, when I divide those, does it mean something? Yes. 80 divided by 40 is 2. This guy typed twice as fast.
So it would be ratio.
Yes, because 0 would mean the person sat down at the typewriter and typed, if they typed 0 words a minute, they sat down at the typewriter and they typed, if they typed 0 words per minute, they typed how many words?
0.
None.
Yeah.
So to be really careful, don't say type 0. 0 means they typed no word, so it means what it's supposed to. The absence of blank, right? In this case, words. All right. So don't forget you can make corrections on that quiz I just gave back. Did everybody get their quiz back? Did I miss anybody? Okay. And just to remind you guys, so that's something you can work on right now if you want to. When you make corrections to the quiz, if you get a better grade on your test and you make corrections to your quiz grade could go up higher.
Also question, this is probably in the syllabus and I could probably go look it up, but since we're right here, when we're doing the quiz and homework makeups, do we redo everything or do we
No.
just?
So two things. Only on homework corrections and quiz and test corrections. Only correct what you lost points on. And don't ever change the original work. Right? So another sheet of paper or in the back of a quiz or something.
Perfect.
Yeah.
Okay.
Yeah.
So for mine, I wrote the right amount of classes, but I went 1 over. Does that mean I also need to recreate the histogram too?
Did you lose points on it?
I think I went
No, you don't have to redo this.
Okay.
Redo this, because you showed me evidence that you know how to go from here to here. This was wrong. If you would have lost points on this, you would have had to do revote.
Okay.
Yeah.
So correcting me like 2, right?
Yeah, you can get help. I can help you. You can get it done. You can say, I'm not turning this in, Jeff. Can you tell me if that looks all right? And then I'll say, this is wrong, this is wrong. And then you'll say, can you help me? And I'll say, yes, I can. So I don't understand people that turn in corrections and get 0 points back. That happens so much. I wish my teachers would have given me some freaking points back. Yes?
Well, can we schedule an appointment with you or before class? How does that work?
So I need to send an email out. I'm in so many meetings this semester, and I finally got them basically set. So now I'm gonna identify, I'm pretty sure Wednesday afternoon I could do some Zoom office hours in addition to my normal in-office. I am not normally in my office for my office hours. Like I come to this room and I go to my other room for my other classes. So I've got to send an email to kind of get that more stable. So yes, you can come to my office hour. You don't have to make an appointment. And I'm going to give you some more options, but you also get less options because I'm in classrooms right before class for those office hours that are right around the class. Yeah. It's wide open if you have any questions. If you're completely ready for the test, you can head out. Did you have a question? Okay. You got your basketball shirt? I got my basketball shirt. This is exactly what goes through my mind when I shoot. No, it isn't.
Does the test usually take up the whole, or like the whole?
I give you the whole time.
Okay.
That doesn't mean that I design it for the whole time. Does that make sense?
When
Yeah.
we're done, do we just leave?
Yeah, you get the hell out of here.
Where do we turn them in, up front?
Yes.
It's always awkward, okay.
So it's funny you say that. I'll never forget my one teacher. People would always try to like throw it at him and then run and I always had to look back and he would pick mine up and he would go, and I'm like, why did I look back? Why did I see him? Why did I have to see that? But I don't do that to people, don't worry. I know what it feels like.
Okay.
Is everybody good? Good enough? Don't forget, we got Monday off, so I'm not even going to be on campus at all Monday. But feel free to email me. I will check my email every now and again. Yes?
That's my load bottle. What was wrong with this one?
Oh,